Hello, everyone, and welcome back to Identity Insights by Indicio. This show takes a look at some of the latest news from around the decentralized identity community and offers you an opportunity to learn a bit more about what Indicio has been up to. Today, we're taking a look at some of the highlights of the recent Indicio Meetup featuring Mark Rakhmilevich, Senior Director of Blockchain Product Management at Oracle, and Mike Vesey, who is the CEO of IdRamp. They're going to be talking about interoperability between Hyperledger Fabric and Hyperledger Indy and discussing a real-world implementation that they worked on together. Without further ado, let's take a look.
We're talking today about Hyperledger Fabric and Hyperledger Indy, two of the technologies, obviously in the Hyperledger Foundation. They are very different ledgers, and they have different purposes. They have different requirements that birthed them, and now so we're talking today about combining them for the features that each ledger actually has.
Hyperledger Fabric was one of the earlier projects that began in the Hyperledger Foundation. Probably going back, 5-6 years maybe now. It's a platform that's built for generic blockchain use cases with the concept of peer nodes that hold copies of the ledger and have ability to execute smart contracts. And those smart contracts are generic business logic that can be written in Go, JavaScript, or Java. So supports multiple languages today. There is a notion of a client, which could be, in our case, we created a separate Oracle REST proxy, which is an API gateway to orchestrate all of the interactions and simplify some of the complexity. But this is essentially a client that sends a transaction request, invoking one or more smart contracts, getting the responses, read, write, sets back, and then sending those transactions, once they've been endorsed and signed by peer nodes, to the ordering service, where the ordering service is a cluster of ordering nodes that's responsible for grouping, sequencing those transactions into blocks, sending the blocks back to peer nodes, where they get verified and then appended to the ledger. So it kind of starts from the client or API gateway perspective, running smart contracts as the execute portion, and then sending them to the ordering nodes, and then the blocks get sent to the peers to be appended to the ledger here. Now, let's talk about how we use it in the solution, Mike.
Yeah, sure. So let's dig into this. So we had some specific requirements, and again, flexibility. Every deployment is going to be unique. And this project required us to integrate, as I mentioned. So the high level was integrating the verification and the authentication of individuals and allowing them to access these government services. So to achieve that, we needed to enable the agencies and departments basically to authenticate against a single set of credentials. And that was difficult because we had, in one of the pilots, there were 141 sites, and there were almost that many identity systems that they were using to access those. So as a resident or citizen, I had a lot of stuff I had to keep track of and manage. And we streamlined that into a single set of credentials. So using the combined solution, we were able to verify the users and actually go back and provision a higher level user in the IDM system that the state organization was using, basically kind of mastering a one identity that would transcend all of those different 141, providing a mutable audit trail of requests, documents, verification steps, and credentials. So obviously that's more of a fabric type solution, right? So in this solution, we would gather these documents and we could store the documents in the OCI, the Oracle Cloud infrastructure on the Fabric system. We could pull them out, issue Indy-based credentials based on the metadata contained within those documents when needed. So the solution, we uploaded those documents. All those documents were held in contracts in Fabric, and as they were reviewed and approved, we would submit those and push them out into Indy-based credentials, which were then used for the actual login process that we're looking at here. So we took 140 services and retrofitted all of them from traditional username, password, login systems to using a digital proof. And the digital proof was asking for different sets of information. So very interesting that we weren't just saying, here's the template and all 141 solutions have to conform to this. Court services required a much different user payload than than say unemployment services or health and human services. So the challenge was getting all of that information vetted on the front end, getting the credentials issued, and there were multiple credentials issued for the different sets of attributes that each citizen would have. And then as they navigate these different places, the beauty of the solution was I, as the resident, I don't have to go and look up a driver's license number that I might need for court services. And that value may not be required for health and human services. So really all the user had to do is interact. All they had to do is scan a QR code or interact with that login system, and the digital proof would ask for the information needed and mine that out of the credentials that were stored there.
In this particular case, we did not actually store credentials on the Oracle blockchain. The Oracle blockchain platform was used for all of the identifying documents to prove that you are the resident and that you're entitled to the services, right? So, and then the verification processes associated with those documents, audit trail, as Mike mentioned, and so on. The credentials were basically run off the private Indy deployment in Oracle Cloud that IdRamp implemented, and then they were able to create those identity credentials and then use basically this passwordless logging mechanism to enable the verified users to go in through the Oracle Identity Cloud service and then verify back, through the IdRamp application that, those users in fact have, various claims, interacting basically with their wallet in a kind of a challenge response mode to be able to get those claims and then fill in appropriate data that's required for some of these different services. So this is actually a little bit more detailed diagram, Mike, that you maybe can talk
sure.
the process here. Yeah.
Yeah. So the process, again, just this conversation started by, the request. The ask was, we want to get rid of passwords across our in our environment, right? So that's
passwords and multiple separate logins, right, into each agency. Yeah.
Yep. We want to simplify the process and get rid of the passwords. And then, as I mentioned, I kind of alluded to in the previous segment, we actually made the system smarter and easier to use because I, as the user, don't have to remember where I get this piece of information. It's all stored in those credentials, and the request, the proof, the request that is coming to me will dynamically mine it. For the password login, here are the things we went through. Basically, we had to submit the data for verification. That's that piece I was talking about, where registration verification. We're uploading our documents. We're verifying our identity in step 2 through automated and manual processes. So, for example, if we captured a driver's license, we could make a direct call out to DMV systems or whatever and do some of that verification in an automated fashion. Other pieces of information, like whether they live in a certain jurisdiction and those address requirements, for simplicity, were just done through a manual verification process. And then once all of that data was good, the administrator, whoever was reviewing that, would basically mark them all as verified, saying, yes, everything is done. And we would get to the credential distribution phase, which is where we push those out. Because our citizens and residents have they came to the site to upload documents, they came to the site and enrolled basically first, we had a connection. So one of the beautiful things about how DIDs work, and I'll quickly get out of my depths if I don't keep it high level, but and so we had these connections that we made. So when that resident came in, we made a connection to them and their digital wallet that they have downloaded. So when we get that identity verified, we don't have to have them come back for that interaction. Instead, we just push the credentials to them. They get an alert on their phone, say you've got some credentials, and they automatically get stored in their wallet once they approve it and provide their consent. So that's an important distinction. It sounds really simple, but it's not the way the world works today, right? It's all basically relying on me to start some action. If I'm doing my driver's license, it needs to be reviewed. Now I got to go back in. It's a very heavy process for the user. this is not. So I come in, I interact, I upload my stuff, and then I just go about my business. And I'm walking on the street one day and I get an alert that my credentials are ready and I'm ready to use those for my, my federated login process for the particular state. So really making the experience much better.
There are a couple of questions here in chat, so
Okay.
we're going to try to answer them as we go through this. So one was, did we create one super credential, or was there multiple credentials tailored to each service? And the other one is the limitation of one using Hyperledger Indy. So the answer to the first question is, based on the residence verification and all of the documents, right? We did create in Oracle Identity Cloud Service, if you will, a master credential, a master identity that the applications could access. And whenever application, there is a large number of applications across large number of agencies. So whenever they're ready to actually start using that master credentials, they can, right? And for the first few, they began using that. That was kind of the objective. But at the same time, as Mike was mentioning, if they need additional information, they can interrogate the wallet. We did not store any of that additional information in the Oracle IDCS. And if they don't need to go through master credential, if they want to continue to use essentially this universal login passwordless mechanism, then those applications could leverage direct connection to the wallet.
Yeah. So we created a master identity, which was a request by the customer and a requirement of the project. But we broke that identity into multiple granular credentials because, as I mentioned, we wanted to be able to be very dynamic in how we presented that information, understanding that each of those different services required a different payload. So, for example, the presentation to the customer was one form: fill in this information, upload your driver's license, whatever the case might be. And then we would break that apart and store those into micro credentials, if you will, that were very laser focused. Address, for example, is much different than driver's license. And, so we were able to really provide the best possible footprint for an end user. And for me as a consumer, it's really easy. I don't have to understand the technology, right? I just get an alert on my phone and it says, hey, you got these three things from the state. Do you want to put them in your wallet? And I say, yep. And they're there. And then I never worry about them again, right?
Thank you all so much for watching. If you're interested in verifiable credential technology and would like to learn more, please be sure to subscribe to the channel and we'll continue to bring you some more educational content. If you have any questions or specific topics that you'd like for us to cover, please leave a comment below and we'll be sure to read and address them. If you'd like to see the full video that these clips are taken from, I'll also have a link in the description below. Thanks so much.